In this video, we are going to be talking about quadratic functions and their graphs. So quadratic functions, remember, the standard form is f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a can't be 0, because if it was 0, we would lose that x squared term, which is that is what makes it the quadratic. So we've seen this standard form a lot of times. But today we're going to be talking about the vertex form. So f of x equals a times x minus h squared plus k. And we're going to break down what each one of these a, h, and k, how they shift the graph. Okay, so quadratic function in general is this parabolic shape, and it has this axis of symmetry, meaning it's going to be symmetrical from one side to the other, and the lowest point or the highest point, if it's a flipped parabola, is called the vertex. And we're going to discover what each one of these parts of the vertex form do, how it moves and shapes this graph. So in particular, in this first video, we're going to be talking about the a term. So we have a function in the form of ax squared. If the a is a positive number, that means that it's going to open upward. So our graph will look like that. That's what I call the happy, because it's making a happy face. If our a value is negative, it'll flip the parabola down, so it's a sad face. If the actual value of a, so the absolute value of a, is greater than 1, it's going to make it thinner. So the standard parabola would look like this, and a thinner one is just, as I mentioned, narrower. If the absolute value of a is less than 1, so we're going to get some form of fraction or decimal less than 1, it's going to make it wider. And then I'm going to talk about how to find some other points as we go. Let's look at this first example. It says f of x equals 3x squared. Alright, so there's no shifts left or right. There's only this a value. There's no h or k value. That means that our starting point, or our vertex, is going to be at the origin here. And that's always going to be true. If it's in this form ax squared, the vertex will always be at the origin, because there's no shifts, there's no h and k values here, so I'm going to start at the origin. And now I need to find some more points on this graph. So there's a couple different ways you could do it. The most standard way, or the way you can't fail, because you can use an xy table with any function, is to make a table and pick some points, find the y values that go with it. So if I started with 0, we would see 3 times 0 squared is 0. So that's our origin here that we already found. If I plugged in 1, we would have 1 squared, which is 1, times 3. So 1 times 3 is 3. So I go over 1, up 1, 2, 3. There's my point. And it's going to be symmetrical, so I'm also going to have a point symmetrical to that over here at -1, 3. And if I want to try one more point, I could plug in 2. 2 squared is 4. 4 times 3 is 12. And that's going to be off of our graph. So this is really the best we can do for now. We're going to go up. Oops. And it's going to be pretty steep, because the next point would be at 12. And same thing here, going up. And I'm trying to make this, it's not very easy on a computer, more of a curve. This is not a V shape, it's a U shape. Okay, so try to make it a U shape as much as you can, so we know it's not a V. It's not a V. And there you go. So we can see that this is pretty narrow, because it's going to go up pretty fast. It's going to get steep quick. Why don't you go ahead and try the example on the right, and I might suggest, because we have this 1/3 fraction here, picking values that are going to be a multiple of 3, right? Because you're going to divide by 3 each time, and that's going to give you nice whole numbers for your graph. Alright, let's see how you did. So we've got the equation in the form ax squared. So we know our vertex is going to be here at 0, 0. Also, you could just plug in 0, and you'd get out 0 for y as well. And then I hinted that you should pick multiples of 3, right? So I'm not going to pick 1. That's going to give me a nasty fraction to graph. I'm going to pick 3. When we plug in 3, we'll get 3 squared, which is 9. And 9 times 1/3, or divided by 3, would be 3. And I still have times a negative, which would make it -3. So I would go over 1, 2, 3 on the x-axis, and then down 1, 2, 3 on the y-axis. And it's going to be symmetrical, so I could go back 3 and down 3 as well. So back 1, 2, 3, down 1, 2, 3. And you could keep going with more points, but this is fine for now. Again, trying to keep that curved shape. And there you have it. And I know, because of this negative out front, that it should be going down. So that's good. And it's a 1/3, so it's wider than this other graph. So a values bigger than 1 are going to be narrower, they're going to be thinner, and less than 1, so 1/3 is less than 1 whole, are going to be wider. I like to think of it as a little tip would be fat bottom girls, right? So it's got a fat bottom, the denominator is larger than the numerator, then that's going to be a wider graph. In the next video, we'll talk about how that k value affects our function.